Hi guys, welcome back to the next video. In this video, we are going to talk about GKE explained architecture and deployment workflow. Now, in this video, I'm going to explain you the Google Kubernetes engine from my perspective, like one of the architecture which I've worked on. And instead of explaining to you what is GKE, I'm going to walk you through this actual architecture design and then deployment and then the operation of GKE in a real enterprise environment, for example, banking environment. So how are we going to deal with this kind of a complex system? We're going to talk about it. I'm going to explain you one by one, like the architecture of this, the cover architecture, the networking, the node pools, auto scaling, security, CI/CD pipelines, and also kind of the design decisions which I had to make in a real project. So these are the items which we're going to talk about. This may be a little long video, so I would recommend you to get some coffee or something with you so that won't be boring. Try to make it interesting as much as I can. That's a promise I can make. So let's talk about the traffic flow from the beginning. So there are a lot of arrow marks going in one over each other. We will try to explain it to you. I'll try to explain to you one by one slowly. Let's first start with how the traffic flows into the system. So as you can see on the first item over here, the users and customers. So this is where the user hits the application via a domain name, which is resolved to a cloud DNS. And then the request goes to the global cloud DNS is over here. And then it goes to external HTTP load balancer, which manages the SSL certificates over here. Ignore the text. So this is where you actually get offloaded on the HTTPS and then start getting into the infrastructure. So there is an arrow mark over here. Sorry about the color. So this goes over here to the private access over here. So it goes to the cloud SQL, blah, blah, blah. So that basically gets there. So before the traffic reaches over to the cluster, we typically put a cloud armor over here or WAF or DDoS rules over here. So this is gonna make sure that typically a cloud armor, which includes DDoS attacks, miscellaneous IP addresses, we can sort them out. And when we know that this traffic is not genuine and there are IP addresses just blacklisted, so when we go get to know that, so automatically this web application firewall kicks in, and as well as DDoS rules, which is like a denial of service attack. So that kind of a issue, I mean, they already know the IP address, which is like malicious. So they have put in those firewall there, which will restrict our application from illegal utilizations. From, from there, the traffic gets routed to Kubernetes using ingress controller. So basically, the traffic gets routed over here into our ingress controller over here. So you can see that this arrow mark from here, comes to this Kubernetes ingress route traffic to service. There's another arrow mark which goes over here, but that is from this pod. Okay, so I got confused. So this arrow mark, which is HTTPS load balancer, that actually comes to the Kubernetes ingress services, which routes the traffic to the actual service which runs on the background. So on a high level, user hits the domain name and the domain name redirects to the HTTPS load balancer. SSL termination happens here. And on top of that, you're going to have the cloud armor, which is WAF and DDoS, which will be looking out for the IP address of your customer, seeing if it's genuine IP address, is it located nearby to you, or whatever wherever the service is hosted, and then basically gets to the Kubernetes ingress services, and then it routes the traffic to the service. Okay, so this is basically the overall flow, or the first starting or beginning of the of your flow. The next one is about the GKE cluster itself. So the Kubernetes ingress is basically the invitation. So basically the incoming traffic comes through ingress and then gets to your services. That's what you're saying over here. The Kubernetes ingress service is routing your application request to your pods. So pods are basically a Kubernetes terminology where you have this something we call it like the collection of containers. So, but before it goes to the pods, it first needs to reach the nodes. So as you can see that there are three node pools over here. Now, node pools are basically the service which host pods or the worker nodes. So normally we call it as the worker nodes. Now you can see that you have the pod name, the node names over here, front end pool, API pool, and a backend worker pool. So we have classified this as three different node pools. Now, as you can see that the private GKE cluster, this is a private stuff. So whatever happens here is this all is private, which means that these don't have connectivity to internet. So which means once your termination of SSL happens over here, all becomes like a local request, a private request until it goes out back to the through the DNS back where it came from. So nodes don't have public IP address. Access is controlled through internal networking or bastion host. There will be a host over here connected to this particular VPC, and only through that host you will be able to access all this infrastructure which is beneath over here. And on the top you have the managed control plane. This is the manager server, and these are worker nodes, the master node and worker nodes. That's how you configure that. Now managers, the control plane basically has this API scheduler, API service, control manager, etcd, and all those configuration, etc., which is going to help it to manage the Kubernetes cluster. So the cluster runs inside a VPC, which is usually a shared VPC model, and this allows centralized network control, and multiple teams and projects can access them. Now let's talk more about this node pool because there is configurations given here as well. So one of the most important design decisions about GKE is how structured the node pool is. So we don't run everything on a single node pool. Instead, we separate workloads based on the requirements. For example, front-end service uses smaller instances. Backend API service may require a balanced compute nodes, and a batch or a worker job may require higher CPU throttling. So these are some of the important decisions you need to make in terms of an architecture point of view. So each of these runs on a separate node pool. As you can see, a node pool may have multiple nodes connected under the node pool, or it may have a single node as well. So it depends on how you configure it. So why does it run under the node pool? Because it improves performance isolation, helps you for cost optimization, allows independent scaling, which is the key difference between a beginner and an experienced engineer. So when you're an experienced engineer, you should know about that. So where we can cut costs, where we have to improve our performance of the system. So this is basically what we are going to talk about. So in detail, I'll tell you where we are cutting the cost. In terms of auto scaling, right? So auto scaling is the one where we have to enable when you want to have a high availability, and making sure that your servers are available at a high load. So there are two levels of scaling in GKE. First is horizontal pod autoscaler, which is called HPA also. So which basically scales autonomously based on the CPU utilization, memory utilization, or custom metrics. And the second one is like cluster autoscaler, which there is not enough nodes to run on a new pod. The cluster automatically adds more node. So these are the two different types of autoscaler. So both are enabled over here on the first one, as you can see over here. Similarly, if the node is underutilized, so don't worry about it if your horizontal pod autoscaler or cluster autoscaler will reduce the number of nodes or the pods under the node pool. So this is also can increase as well as it reduces. So this actually saves a lot of cost when it comes to managing your application. So very important thing is that configuring the autoscaler. So that's one thing. The next one is about the service over here. So we have this pod over here called web and UI pod. And then you have the deployment over here, and then you have the service over here. So deployment is a word which is in terms of your Kubernetes. We have something called a deployment, and that basically deploys your application across multiple pods, and it creates a replication for it, and that replication will be controlled by HPA. Now, node, as you can see over here, it's mentioned over here. And also we have mentioned over here what kind of an instance we are using. So because we are using E2 standard 4. So you can actually go to Google and you can type in this particular instance type and see how much amount they are charging for that. So that's another option for you. And here you have the API pool. We are using N2 standard 4. And here we are using background worker pool for spot instance or I mean, like it's optional how you want to do this. Either you can go for on-demand instance or spot instance. And here is basically cost optimized over here. And here we have mentioned auto scaling is 2 to 10 nodes. So we are defining that auto scaling should be from 2 to 10 nodes, and maximum we are defining it as 10 nodes. But here there is no maximum definition. So unless this node settle down, it's not going to reduce the number of servers it has spinned up. So basically, that's the difference. Now, when you talk about the services over here, the Kubernetes are deployed in ephemeral storage, meaning that when you create, meaning that they can be created or destroyed anytime. So, which means that ephemeral is basically like this deployments pods deployments will be there, but then the pods and the container which is inside the pods can be destroyed at any point of time and will be recreated instantly as it fails, or if there is any problem detected, it's going to do that. So services needs to provide a stable endpoint for accessing these pods. Now, services is so more important for us. Why? Because services enables you, irrespective of the pod status, irrespective whether the pod is available or not, services will give you an endpoint which means it will have an IP address, it will have a port number. So this endpoint will point to all the pods which is available. So for example, you have 10 pods running and the 5 pods have failed for some reason, you have 5 more pods. So what service would do is like the service will listen on a specific IP address and port number on all these pods, right? It will take all those inputs and then it will project only one port number and an IP address. Okay, so that basically means that it is doing a load balancing in turn, where it gets all this client from these IP address and port number from all these pods, and then projects only one IP address and port number. So whenever someone accesses the service, basically it redirects to any of the pods which is running. So if 10 pods out of 10 pods, 5 pods fail, and then it immediately recreates those pods. That's the whole work of your control plane. So basically what the service does is like it will only show those 5 which is running. So the moment it detects that those URLs are not running for the 5 pods which has failed, it's not gonna send customers to those 5. So it's gonna only send customers to those the 5 which is running. So it basically works like a load balancer. If you know the load balancer concept, it basically works like that. You have different types of services which can be configured. You have cluster IP, you have node port, you have load balancer likewise. So cluster IP is used for internal communication. Node port is used for to export this particular service into your system where the node is running. So that's basically external access. And then load balancer is where it integrates your cloud and creates a URL for your application. So it will be a unique URL, so that will be accessed from your load balancer. So we normally use cluster IP address because we export this service, and then from the service we use ingress to export that service from the service. So ingress side on top of the service manages the external routing. So for example, this one over here, ingress we configure over here. So this is where basically will be sitting on top of the service, and all the incoming connection will be connected to ingress, and ingress will route the service to the service, and service routes to the deployment. deployment routes to the pod where the service is running. If the service needs more allocation, more resources, then the control plane will understand that by looking at the CPU memory or custom reference, and then it starts spinning up more pods, more nodes, however it is designed to compete with that. So, for example, you have two APIs over here. So you have the web API. So you can see that. So here you have the slash web, which goes to the front end. So when application requests slash web, it goes to the front end, or slash UI, it goes to the front end. When the application is typed name with slash API, it goes to the second node pool. So basically, it's a service to service transaction from UI, which is going to be like either it's going to be the front end or the API pool. It's going to do that. Now, on the other hand, the node over here is not configured to attract any kind of a direct customer request, because these are configured with web and API as a redirect symbols or URIs. But this one, on the other hand, is not configured to be as a receiving directly from the customer, but rather it will be receiving from the services, which is processed by this particular node pool too. And that, for processing it, it goes over here. And sometimes this node pool can also send data to this Cloud SQL scanner or memory share. So this will also be there. So that's why I put an arrow mark over here, which goes and connects here, and as well as like it connects to this node pool as well. So this is for asynchronization job. So let's talk about the CI/CD pipeline over here for a second. So the CI/CD pipeline is over here. So this is where you kind of declare your or you typically define a flow, which looks like a developer pushes the code to the GitHub, and the code builds, or another CI tool builds the container image. The image is going to have the full artifactory. So there is an arrow mark over here. Sorry about that. There is an arrow mark over here, which is connecting from the build scan push deploy to the artifact registry over here, which is your container image. So this container image is going to have an operating system. It's going to have the minimalistic operating system which it needs to run. It's going to have the image of your application as well, which is tested already, because this is the pipeline which comes from a deployment, a development UAT to production. So once it comes over here in this particular artifact repository, then the artifact repository will pull this image when another deployment is scheduled. So basically that image is pulled over here, and that image, GKE pulls that image and deploys it to Kubernetes manifest or Helm. So there are two methods of deploying manifest or Helm, which we will talk in Kubernetes classes. So those are deployment methods, or the templates for deployments. So we also use rolling deployment to ensure that there is no or zero downtime. If anything goes wrong, you can always roll back, which is roll back to the previous version, the available version. In more advanced setup, we will use Git tools like Argo CDs, things like that, and we'll try to understand more what happens in this architecture. Well, in terms of security standpoint, over here, you have the security over here and then logs over here. So all this logs which happens in node pool 1, 2, 3, your control plane, all those logs will be transferred to cloud monitoring or logging through Prometheus Grafana, which is optional, and the SLI, SLO alerts and blah, blah, blah. So basically your metric logs will be transferred over here. So in terms of security, which is implemented at multiple levels over here. So at the cluster level, we have the private cluster. So this cluster itself is a private cluster. So it is hosted on Europe West 2. As you can see, this is a private GKE subnet cluster. So this subnet itself doesn't have public connectivity. So none of the servers which is hosted within it would have the public connectivity. So all those communication will happen through ingress, and then it goes out through the same way it came in. And then the identity level, we use IAM for identity items, like for example, the roles assigned to the groups and the groups assigned to the users. And workload identity uses service account keys, and that's basically the service account will be coming into picture for all your applications to connect between each other. And at network level, firewall rules and network policies are applied. That's gonna make sure that you have good connectivity and making sure that you reject all those things which is not related to you. And also you have the cloud armor over here, so that's at the top level. And secrets are stored in the secret managers. So secrets as in which is you need to be used on these particular worker nodes will be all be fetched from the secret manager, because it's all common to the entire infrastructure. So all these secrets will be shared across, so you don't have to hard code any kind of username, passwords, environment variables. Nothing needs to be hard coded, so it will all be pulled from the secret manager. So pretty much that. And monitoring we already discussed. So running Kubernetes is not just deployment; it's also operating. It's also operations of its reliability. So when we use cloud monitoring and logging to trace, you have CPU memory errors. So these are three important things which we consider. So we also have SLI and SLO for to measure the system health, like for example, 99.9% availability and response time thresholds also we would monitor. And the alerts are configured so that the team can respond quickly, and incidents will be created as well if in case of any issues. Tools like Prometheus and Grafana are also used commonly to understand the graphical way of putting things up, so that's easy for the management to understand. Now, cost versus performance. So this is the kind of a high level thing. So when you talk about cost versus performance, finally, a key responsibility of an architect here is balancing the cost and performance. Now, for example, using auto scaling to avoid over provisioning, that is one of the best things we can do. And then using predictable nodes for non-critical workloads, like you know something which we can oversee. And optimizing node size based on the workload is also one of the things which we discussed earlier. All right, so now this is how a real case design looks like. I hope that I've explained you all these items over here. It's just in that. Do put it on the comment section if I missed some of them, or if you want to know more in detail about a certain topic. Now, it's not about just about the Kubernetes knowledge, but also combining network security, scaling, and automation together. This will prepare us for to become a good architect or a good lead for Google GCP, and not just GCP, Kubernetes as well, because all the cloud works the same way. So, irrespective of you using GCP, AWS, or Azure, all the concepts here are going to be the same. Just the environment you work on would be different. All right, thank you so much for watching this video. I hope that it was quite useful, and I'll see you in another video with new information.